In this video, let's study a brief overview about what is continuity. Now, as the name suggests, continuity means something continuous, and something continuous means there is no stoppage or hindrance in between. And in mathematics also, continuity in calculus especially means that if you have any graph and in that graph you can draw that graph continuous manner without any holes, without any jumps, without any breaks, that graph or that thing or that function is said to be a continuous function. The graph of that function, if it does not have any break or any holes or any jumps, then it is a continuous function. So, this graph that I have shown to you is a graph of a continuous function. But if I have a graph like this wherein I draw it somewhere like this, then I have to stop and then again the graph goes like this. You see there is a hole in this. That is why this kind of a graph is called as what? It is called as a graph of a non-continuous function. So, that means I also come to know by this that in any kind of a graph, if I do not have to lift my pen or pencil and continuously I can keep it drawing, then it is that for a continuous function. But if I am going to draw a graph and I have to stop, lift my pen or pencil and again I have to continue drawing, that means it is a graph of a non-continuous function. So, here I have a graph which has x-axis and y-axis. There are L, M, N on the y-axis, there is A and B on the x-axis. The curve is basically drawn with the help of the red ink and the black ink is used to support the graph. Now, what happens is at x is equal to A. I have given the heading at x is equal to A. What is the story? Let's see. For x is equal to A, when I have x equal to A, I see that my curve is already there. If I approach A from the left hand side, that means if I am talking about limit wherein I have left hand side, that means here I will be writing B, there I will be writing A. That means here if I approach from left hand side, it is left hand limit. If I approach from right hand side, it is right hand limit. So, talking about the left hand limit, you see that the curve, if you approach A from the left hand side, gives me the value something here at L, right? But if you approach the same curve from right hand side of A, from right vicinity or neighborhood of A, the curve, if you approach from right hand side, right hand side, right hand side, is what? It is giving me something else, and here if you see that, okay, both are tending towards the same value. When here it is A, from left hand side also I get L. When here it is A, from right hand side also I get L. But is the graph still continuous? I see it by actually overwriting or again redrawing the graph. Redrawing with the help of a black ink tells me that, okay, here I don't have to stop. But then there is a hole, I have to stop, again I have to continue below. That means there is a hole, so it is not continuous. So, even if what happened was my left hand limit and right hand limit were equal, A negative means left hand limit for the function if the name of the function is fx, that was equal to the right hand limit, which is A positive always shown for fx, and both these gave me the value of L only. Here you see it is L. So, I just make a separation line, both these give me the value of L, but still what the problem was? The problem was there is a hole in between the graph. The hole in the graph tells me that the function is not continuous. So, even if I see that the limits are equal, LHL is equal to RHL, the story does not end because of the presence of the hole or a break or a jump in the graph. What happens is I see that my function becomes non-continuous. So, here the thing was that I saw it is a non-continuous case. Why? Because there was a hole or a break in it. And again you move to now B. You see that when I have B, when I have x is equal to B, what happens? For B, either I can approach from the left hand side or again I can approach from the right hand side. If I approach from the left hand side, what do I see? I see that approaching from left hand side and right hand side makes things something different. Approaching from the right hand side, the curve is this way, right? It goes somewhere here and this is N. Approaching from the left hand side, I see that I approach from the left hand side, left hand side, left hand side, and it switches till here, then stops at M. So basically these things are not equal. My left hand limit and right hand limit are not equal in this case. That means when I saw x is equal to b minus for the function, x tends to b minus, and when I saw x tends to b plus, I discovered that these two things are not equal, and when these two things are not equal, that means what? That means, can I say my function is continuous? Not at all. And again with the help of graph, let's see. You see that there is some distance, there is a kind of jump from here to here, and the jump case also tells me that there is no continuity, so it is non-continuous. One more U has to be there for the correct spelling. Now these two cases we understood that when the limit is equal but there is a hole, then you say that it is not continuous. You see that when the limit is not equal, that means when I have LHL not being equal to RHL, also we see that there is non-continuity. In one more case there is non-continuity. For more insights to that case, stay tuned for our next videos. That would be the case wherein we will be studying discontinuity in detail. That I didn't take up in this video, but remember there are more cases, one more case wherein the function is non-continuous.